Okay, we're going to work on polynomials. And the definition of a polynomial is an expression with many numbers or terms. An expression with many numbers or terms. Let me get my pen ready. Yeah, an expression with many numbers or terms. An example of a polynomial would be, let's just make something up, 5x to the third minus 2x squared. Right? You can have numbers, we can even put like +1. You can have numbers in there, you can have different degrees in there, it doesn't totally matter, it's just an expression with many numbers or terms. The degree is the highest exponent in the polynomial. The highest exponent in the polynomial. So I'll give you an example of how we classify the degree of a polynomial. If I give you something like 8x cubed minus 4x plus 7x to the fifth, let's just say plus 3, right? The highest exponent, the exponents are what I'm raising my variables to. This is x to the 0, this is x to the third, this is x to the first, and this is x to the fifth. So the highest degree would be x to the fifth. So the degree of the polynomial would be degree 5. For term, a term is a number or variable separated by plus or minus. So a term is numbers or variables separated by plus or minus. Okay, so you're not separating by multiply and division. So when I have something like, again, 2x to the third minus 4x, those are two terms, because this is a term and this is a term. It's separated by a subtraction sign. I could change that to addition and it would still be two terms because it's separated by plus or minus. Okay, like terms are terms with the same variable. Terms with the same variable. Doesn't matter what variable it is, but if they have the same variable, they're like terms. So example would be, 4x and 5x. Those would be like terms. Standard form is when we take our polynomial and we write it from the greatest to the least exponent. So I'm going to say polynomial written from the greatest, or I guess, the biggest, to the smallest, or to the least or smallest exponent. All right. So if you look up above, kind of just right here, that's already in standard form because it goes from degree 3 to degree 1. All right. The one above it is not in standard form, and we'll work on that in just a minute. The leading coefficient, well, coefficient, if you remember, is the number in front of a variable. So the leading coefficient is the coefficient on the term with the biggest exponent. So I'm going to say the coefficient, again, you need to know what coefficient is. It's the number in front of the variable. The coefficient of the term with the biggest exponent. So let's look at the one I circled again. The biggest exponent is 3. So the leading coefficient is going to be 2, because 2 is the number in front of the variable. And once you put it in standard form, really, if you're in standard form, the leading coefficient is always going to be the number that's out front, because it's going to be the number in front of the highest degree variable. All right. And end behavior is what we're going to work on last. I'm going to give the definition now, and we'll revisit it later. But it's the direction of the left and right ends of a graph. It's the direction of the right and left ends, meaning like where does it end? Is it up? Is it down? Where is it? Ends of a graph. All right. So those are going to be the, 7 things that we're working on today. We're defining them and we're going to kind of apply them in different problems. So first thing we're going to do is name our polynomials using the degree of the polynomial. All right. So we're naming using the degree. If something has 0 degree, it would be like x to the 0 power. Well, anything to the 0 power is really just 1. And so anything to the 0 power is a constant. So we would name anything to degree 0 a constant. Degree 1 would be like x to the first power. Okay, x to the first power is when I just have an x in my expression. And we've learned before, if we have x's in the expression, that's going to be a linear expression. If I use it degree 2, it would be x squared. Well, x squared, you should remember, anything raised to the second power is a quadratic. So we would name that a quadratic. X to the third is going to be a cubic. X to the fourth degree is going to be quartic. Think of quarters, quartic. X to the fifth is going to be quintic, quintic. Now, after we go to quintic, if I have x to the sixth, if I have x to the seventh, if I have anything bigger than 5, you're going to name that as a polynomial. Just erase this, I don't know what I did there. Polynomial of blank degree. So if it's to the 7th degree, you'd say this is a polynomial of the 7th degree, 8th degree, 9th degree. So you can name up from 0 to 5. After the 5th degree, they stopped giving specific names, and it would just be a polynomial of whatever degree. Okay, let me scroll down a little bit. Now, if we were to name polynomials using the number of terms, if there's 0 terms, well, that would be none. Okay, you can't actually name something if there's nothing there. But if you have 1 term, all right, that's going to be a monomial. Monomial. Okay, think of mono as in 1. Well, if monomial is 1, when I have 2 terms, and we've used this word a lot, is binomial. A binomial is when we have 2 terms. 3, if I have 3 terms, that's a trinomial. And after those 3, anything bigger than that, they're just going to name, or you're going to write it down as a polynomial with blank terms. So if it has 7 terms, you say the polynomial with 7 terms. There isn't a specific name after monomial, binomial, and trinomial. Okay? Now, we're going to go into learning about graphs, and that way we can talk about end behavior in a moment. Okay, if y is equal to a number, all right, we should know y equals a number or horizontal line. So anytime I have a y equal to any number, it's going to be a horizontal line. Right? Y equals x is a linear graph, and we should know that if it's just y equals like a positive x, my line's going to go up and to the right because my slope will be up, 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 and right. Whereas if I have a negative x, it would go down, right, and right, because I would have a down slope, down and right. So we know what lines look like. If we have an x, it's going to go up and to the right. If I have a negative, it's going to go down and to the right. X squareds we should be familiar with as well. We know those are quadratic functions, and so they're going to be parabolas. So my x squareds are going to be facing up. However, that's if I have a positive x squared, right? We talk about that a value. If it's positive, it's a smiley. If it's negative, it's a frowny. So we're going to build on that and talk more about x cubed graphs. X cubed graphs, if I have a positive x cubed, it's going to be a squiggly where I start down, okay, and kind of make a little curve, and I go up. That's what the shape of an x cubed graph looks like, and that's something that you guys need to know. If we do the negative of that, it's going to flip over. So instead of starting down and ending up, it's going to start up and end down. All right, so this would be the graph of an x cubed. Now what's cool, and this is what we're going to explore with polynomials, is if I know these basic 4, I know any polynomial, because any evens, so if I look at like x to the 4th, that's an even number. Any even number is going to follow the y equals x squared pattern. So even though it's x to the 4th, or if I'm going to jump here to x to the 6th, those are both even numbers. So if it's any even number, it's going to follow the same pattern as x squared. So if I have a positive x to the 4th graph, it's going to be up, up. Now it's going to be shaped kind of like a W, okay, and it's going to be shaped many different things depending on what is next to the x to the 4th, but it's still going to, the end behavior is still going to be up, up, okay. If I had a negative x to the 4th, then what I would be doing is going down, down, okay. Just know, what's important is the x to the 4th graph follows the same end behavior as the x squared graph. I'm going to jump to x to the 6th just because that's another even number. Anytime it's even, it's going to follow the pattern of x squared. So I know it's going to be up, up, but when I have x to the 6, I'm just going to have a couple more bumps in there, all right? But what you guys need to know right now is we're just going to focus on the ends of the graph. If it's a positive x to the 6, it's going to be up and up with some bumps. If it's a negative, again, it would just be down, down. And those bumps could vary their height, their size. We're just doing a general outline and a general shape of the graph, okay? Now, x to the 5th, that's going to follow your x to the 3rd graph, okay? So if I have x to the 3rd, that's an odd number. Any odd degree is going to follow the same pattern. So an x to the 5th is going to look something like this. It might have an extra bump in there, but it's still down up if I'm an x to the 5th and I'm a positive. Again, if I have a negative, it's going to take that graph and it's going to flip it over, so it would look something like that. All right? The last example we gave was just like a big polynomial where you have lots and lots of terms. But what we want to tell you is it does not matter what is here. Whatever the highest degree is, that is what carries weight, and that's going to tell you what the shape of the graph looks like. So if it's x to the 6th, that's an even number. And since it's an even number, it's going to follow the same suit as x squared. I know that my graph's going to start up. I might have some squiggles in here somewhere, and it's going to end up. All right? So getting a little more specific with end behavior. We're going to kind of take what we just learned. If we have an even degree, so x squared, x to the 4th, anything like that, x to the 36th, right? Any even degree, and I have a positive leading coefficient, so it's like a positive x squared, a positive x to the 4th, all right? I think of it as if I had an x squared, I know my parabola is up, up. So if I have a positive leading coefficient, my end behavior, meaning the left side of my graph, is going up. I put a comma. Where's the right side of my graph going? Well, it's going up. All right. Whereas if I have a negative leading coefficient, it would be a negative x squared. And we've talked about this before. If it's a negative x squared, right, a negative x squared would mean that I'm a frowny. Well, no matter what even number it is, whether it's a negative x squared, negative x 4th, my end behavior is always going to be down, comma, down, because the left part of my graph was down and the right part of my graph was down. Okay, let's move on to odd degree. So now we're talking about like x to the 3rd, x to the 5th, x to the 7th, any odd degree. I'm just getting a different color, so let's go blue. If I have an odd degree, x to the 3rd, like I said, x to the 7th, whatever you want, you think about that in terms of a positive x cubed. If I'm on a positive leading coefficient, it would be positive x cubed. I need to know that x cubed graphs look like down up. So if they look like down up, my end behavior is going to be down, up. Okay, whereas if I had a negative leading coefficient, so it was like a negative x cubed, I need to know my graph would be flipped over. So any negative odd degree, any odd, and it's negative out front, is going to be up on the left and down on the right. And that is what's called your end behavior. So we need to learn about x, x squared, x cubed, what their graphs look like, so we can kind of mimic that behavior for things of higher degree. Okay, so we're going to go ahead and kind of put together all the things we just did on the first page. The first thing we're going to do is write the polynomial in standard form and then classify it by degree and number of terms. So look at number 1. If I want to make it in standard form, I have to go from highest degree to lowest degree. Okay, the highest degree is going to be 5x to the 4th and then minus 7x. I put it in order from the highest degree to the lowest degree. Then I want to classify by degree and number of terms. So you're probably going to have to look back at your sheet till you have these things memorized. The degree is 4. The way I name something with degree 4, again, is a quartic. And the way I name it by number of terms is we'll count how many terms. I have 2 terms, so 2 terms is going to be a binomial. So that would be called a quartic binomial. All right, look at number 2. Let's put it in standard form first before we classify it. So 3rd is the highest, then squared, and then I'll combine those x's. So let's say 3x cubed plus x squared minus 2x. There's my simplified expression. It's now in standard form. So what I'm going to do is say, okay, how do I name that now? Well, I have a 3 for my highest degree. That would be a cubic. And again, you can look at page 1 if you need help. Number of terms, I have 3 terms now. When I have 3 terms, it's called a trinomial. So you have to have memorized what the degree and how to name it by degree and number of terms. Let's try number 3. Put it in standard form. It's going to be negative 2x to the 5th plus 6. Go ahead and try to name that one. Right, so if I name this, it's going to be what? To the 5th power is quintic, and 2 terms is binomial. Right? Number 4, now this looks like it might be 4 terms, looks like it might be linear, but once I combine, I have to combine first. I get negative 2x. I actually have nothing left over. Negative 2x, x is linear, right? But since I only have 1 term, it's going to be a linear monomial. Right? So you need to know the names of the degrees and the number of terms. Okay, 5, 6, and 7, we're going to have to do some simplification before we put it in standard form and then classify it. So if I'm subtracting this quantity, I'm going to leave my first quantity and then I'm going to change the signs in the second quantity. Now I'm going to put things together and I'm going to write it in standard form. So 2x squared minus 3x squared is minus x squared, and then 9 and 7 would be 16. So that would be my polynomial in standard form. Since it's x squared, it's going to be a quadratic, and since there's 2 terms, it's going to be a binomial. Try 6 and 7 on your own, and then come back and see if you got the correct answers. Just press pause in the video and then come back when you're done. Okay, so on number 6, I would suggest multiplying these two first, 3x squared, and then multiply it by 2x plus 4. You can do it different ways, but I think it's the best way to minimize mistakes. If I distribute, I have 6x to the 3rd plus 12x squared. That's my polynomial in standard form. Since it's raised to the 3rd power, it's a cubic, and it's 2 terms, so it's a binomial. So hopefully you put there a cubic binomial. On number 7, whenever you have things, multiple binomials to FOIL, what I suggest is leave one of them out front, and then let's take x minus 3 times x minus 3, FOIL that first, and then we'll worry about the x plus 2. So if I have x plus 2, if I FOIL these, it's going to be x squared minus 3x, so that's minus 6x. Negative 3 is 9. Now I'm going to have to distribute and take the x and multiply it by all terms, and the 2 and multiply it by all terms. So let me start with the x. X times x squared is x to the 3rd. Then I would get minus 6x squared plus 9x. If I take the 2 and multiply it by all terms, I would get 2x squared minus 12x plus 18. I need to put that together, and then I need to classify it. So if I'm putting it in standard form, look for the highest degree. Well, x to the 3rd is the highest. Then I'm going to put together my square terms, so minus 4x squared. I put together my x terms. It looks like it's minus 3x, and then the 18 just comes on down. Well, I know since I'm to the 3rd power, so here's my standard form, it's a cubic, but it has more than 3 terms. It has 4 terms. And if you remember, we would just say, this would be a polynomial with 4 terms, because we don't have any names past a trinomial. All right, last section is determining the end behavior, and this gets super easy once you understand the even and the odd powers. So what I mean by that is, let's look at number 1. This is 2x squared, all right? If it's 2x squared, it's a squared power, it's an even power. Any even powers, when they're positive, are like your parabola. So this would be end behavior of up, up. All right, number 2. You've got to be careful. That's not in standard form. And you don't have to put it in standard form, but you do need to look at what the highest degree is and if it's positive or negative. This is a negative x squared. So I know it's even. If it's even and it's negative, it's going to be like an upside down parabola. So my end behavior is going to be down, comma, down. On number 3, the highest degree is an odd. It's x to the 5th and it's positive. So if I'm an odd and I'm positive, I'm going to follow the x to the 3rd graph. So my end behavior on the left side is going to be going down, the right side is going to be going up. But if you don't know what an odd behavior is, right, or you don't know what an x cubed looks like, you're not going to be able to do this. So you need to memorize that chart. Let's look at number 4. Now I have the highest degree being negative 5x to the 3rd. That's a negative odd power. Negative odd powers are going to follow negative x cubed graphs, which should look like what I just drew, so I know I'm going to go up, down. All right. Number 5, the highest degree is negative 3x to the 6 is the highest degree term. So if 6 is my even power and it's a negative even. I know negative evens are like an upside down parabola, so it's down, down. Now, number 6 is just a linear graph. If I went like up 7 and my slope was 2, I would have an equation of a line. If I have an equation of a line with a positive slope, my graph's going to look like down on the left and up on the right. Whereas, let's jump to number 8. 3 minus 5x, if I wrote that as like negative 5x plus 3, that would be a y-intercept of 3, and my slope would go down 5 over 1. So my graph, when I have a linear function with a negative slope, my end behavior is going to be up, down. And lastly, let's look at number 7. The highest degree term is negative 7x to the 5th. So it's a negative odd power. A negative odd power is going to look like this. So it's going to be up, down.